Namaste one and all. My name is Arjun Joshi, Assistant Professor, Department of EEE, VVIET, Mysuru. In the last video, we actually discussed about voltage follower with design. We actually designed the circuit manually and in the multisim software, and we saw the outputs. In this session, we continue with our first experiment, that is the design and analysis of voltage follower, inverting and non-inverting amplifier. In this session, let's discuss about both amplifiers like inverting and non-inverting amplifiers. Okay, yes. This is nothing but the aim of the experiment and operators required theory. I'm not going to discuss these things. I'm directly getting to the design part. Before getting to the actual design, we should know two formulas, that is nothing but gain formula, voltage gain or closed loop gain. ACL equal to AV, both are same, equal to minus RF divided by R1. RF is nothing but feedback resistance. R1 is nothing but input resistance. Output divided by input is nothing but gain. Okay, ACL equal to RF divided by R1. Here minus RF divided by R1. Minus represents 180-degree phase shift between input and output. Output formula V naught equal to ACL into VI. Here, this gain will going to multiply with our input voltage. For example, I'm going to give, if I'm going to give 2 volts, output will going to multiply with this gain, whatever it may be the gain. Okay, yes. Now, to take one example, take one example. For example, assume voltage gain equal to 10 and then R1 equal to 1 kilo ohm. In that time, what is the gain formula? ACL equal to minus RF divided by R1. Substitute AV value 10 equal to minus RF divided by R1. RF equal to 10 into 1. Why? R1 value 1 kilo ohm. 10 into 1, R1 equal, RF equal to 10 into 1 equal to 10 kilo ohm. Okay, we find RF value, R1 equal to 1 kilo ohm, RF equal to 10 kilo ohm. VI equal to 2 peak to peak, AV same, 10, AV 10, V naught equal to ACL into VI. V naught equal to ACL, substitute the value of ACL or AV 10 into VI 2 equal to 20 volts. 20 volts peak to peak. Okay, if we give 2 volts peak to peak, output should be 20 volts peak to peak. Okay, now let's get it to the multisim software. What is the input voltage? 2 volts peak to peak, which that circuit should give 20 volts peak to peak. That is the main agenda of this inverting amplifier. Simultaneously, it should give 180-degree phase shift. Okay, shall we simulate the circuit in the software now? Okay, this is the simulated circuit. Okay, I will show how to simulate now. Now, this is the editor window. Now I'm going to choose the components with the help of this place component. Okay, choose all groups. You can directly type here what are the components required. 741 IC, 741 IC, op-amp IC. Just click on the OK button, and then here next what are the components required. VCC 15 volts. Just type VCC. Then VEE. Okay, next what are the what other components required? Resistors, 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 resistors. 2 resistors are required. Okay, next ground, ground, ground is required. Yes. Okay. Okay, next. This is nothing but our signal generator and choose two channel oscilloscope. The first step is we should do this negative negative ground. Okay, copy, paste, paste. Okay, then get into this bam. 7 is nothing but plus VCC. This control R, this we can rotate. VEE connected to 4. This is nothing but negative VEE. Next, this register to inverting terminal, and then I'm going to connect this inverting terminal to positive because it's the inverting amplifier. That's why I'm going to connect it this inverting minus pin 2. This is to this positive signal generator terminal. Then ground we record for signal generator. Copy, paste, common. Yes. Next, this is nothing but feedback resistor. We can change this one R2 to RF, RF, RF. Okay. Now this resistor to 2, 2, 2, then 6. Okay, done. Almost circuit is over. This A channel I'm going to connect to input. This output B channel to output. That is nothing but terminal 6 or pin number 6. Okay, we know the pin diagram. 3 is nothing but non-inverting terminal. 2 is nothing but inverting terminal. 7 is nothing but plus VCC. 4 is nothing but minus VEE. 6 is nothing but output terminal. Okay. Yes. What is the input we need to set? 1 hertz. It may be 1 hertz or 1 kilohertz, whatever it may be. Okay. Input 2 volts means there is no V peak to peak here. We need 2 peak to peak voltage. We should give 2 volts peak to peak, but there is no option here. So that's why I'm going to take V peak. That is nothing but 1. We should divided by 2. Okay. 2 by 2, 1. If in case in the question, if they are asked to give 20 volts peak to peak, in that time you need to divide it by 2, that is nothing but 10 volts. Okay. Yes. Close. Then run the circuit. You can observe the output here. We should change this one to 15 into minus 15. Okay. Now run. Output is coming. For differentiate the output and input, I'm going to give this color to blue. Okay. Yes. Now reverse for better looking. What is the RF value? RF value we should keep 10 kilo ohm as per the design. As per the design, R1 value 1 kilo ohm. Where is the design? R1 value 1 kilo ohm, RF value 10 kilo ohm. 10 kilo ohm. Okay. Yes, 10 kilo ohm. Now you run. What is the expected input voltage? What is the input voltage? We should give hold. Okay. Now you can measure what is the input voltage. Here you can observe signal generator 1. 1 is nothing but 2 volts peak to peak. 1 V peak, that is nothing but 2 peak to peak. Observe here from input red color is nothing but red color waveform is nothing but input waveform. The input waveform covers two boxes. Two boxes into this 1 volts per division is nothing but 2 volts. Okay, 2 into 1. That is nothing but 2 volts peak to peak. What is the output? Blue color waveform. 1 box, 2 box, 3 box, 4 boxes. It covers 4 boxes. 4 into 5, 20. That is nothing but now input we gave 2 volts peak to peak. The output is 20 volts peak to peak. This is how we should calculate manually. Otherwise, there is an automatic option with the help of these scalars. Okay. Yes. Peak to peak. Peak to peak. Okay. What is the input voltage? Actually, we gave the input to A channel, output to B channel. Okay, observe here, A channel 1.9, that is nothing but 2 volts, approximately 2 volts. Expected output 20 volts, but here 19.2. It's okay. Okay, 2 volts input, 20 volts output, peak to peak. This is how we should calculate we should see the output with the help of multisim. Otherwise, that one amplitude. Then how we can measure the time from the 0 degree to 360 degree. You can take any one full waveform from here to here. You can take any one from here to here. You can take any one. What is the time here? 994.318 microsecond. What is the frequency formula? F is equal to 1 by T. 1 divided by 994.318 microsecond is nothing but our 1 kilohertz. You can calculate. That will give 1 kilohertz. Okay, this is how we should simulate the circuit with the help of multisim. Okay, now let's discuss about non-inverting amplifier. Before getting to the multisim simulation, let's understand the concept of the design theory or design concept. Okay, yes. Here there is a design, very simple design. Here also we should know two formulas. AV or ACL equal to 1 plus RF divided by R1 in the inverting amplifier. ACL or AV equal to minus RF divided by R1, but here 1 plus RF divided by R1.